Last, we evaluate the limit. Notice how we have the limit of a complex fraction as t approaches 3. If we try to perform direct substitutions to determine the limit, notice how in the numerator we have 1/5 minus 1/5, which is 0. In the denominator we have 3 minus 3, which is also 0, giving us the indeterminate form of 0 divided by 0. This does not mean the limit does not exist. We can often perform algebraic techniques to change the form of the function that will then allow us to determine the limit by performing direct substitution. In this case, we'll be using method 3, where we'll use the least common denominator. We can approach this two ways. One way is just to subtract the fractions in the numerator as the first step. A quicker method would be to notice that the least common denominator is 5 times the quantity t plus 2, and then multiply the top and bottom of the complex fraction by that product. I'm going to go ahead and show the longer steps of subtracting the fractions in the numerator. So beginning with the complex fraction, if we needed to subtract the fractions in the numerator, we would have a common denominator, or least common denominator, of 5 times the quantity t plus 2, and therefore we'd multiply the numerator and denominator of the first fraction by 5. We would multiply the numerator and denominator of the second fraction by t plus 2. And now let's go ahead and subtract. Again, we have a common denominator of 5 times the quantity t plus 2. The numerator is now going to be 5 minus the quantity t plus 2. Let's go ahead and simplify 5 minus the quantity t plus 2. We would have 5 minus t minus 2, and 5 minus 2 is 3. Let's write that as negative t plus 3. From here, remember, a fraction bar represents division. Dividing by t minus 3 is equivalent to multiplying by the reciprocal of 1 divided by the quantity t minus 3. So let's write the complex fraction as negative t plus 3 divided by 5 times the quantity t plus 2 times 1 over t minus 3. Now from here, if we analyze negative t plus 3 and t minus 3, these are opposites. Notice for negative t plus 3, the t is negative, the 3 is positive, and for t minus 3, the t is positive and the 3 is negative. So we'll factor out negative 1 from negative t plus 3, which will give us negative 1 times the quantity t minus 3. Let's rewrite this one more time. We have negative 1 times the quantity t minus 3 all over the product of 5 and t plus 2 times 1 over t minus 3. From here we can see we have a common factor of t minus 3 between the numerator and denominator. T minus 3 divided by itself simplifies to 1. So the complex fraction simplifies to negative 1 divided by the product of 5 and t plus 2, which means you can write the original limit as the limit of negative 1 divided by the product of 5 and t plus 2 as t approaches 3. Notice the simplified function is continuous around t equals 3, and therefore we can determine the limit by performing direct substitution. Before we do this though, I do want to show how we could have simplified this complex fraction in a few less steps. So beginning with the original complex fraction, if we recognize the least common denominator is 5 times the quantity t plus 2, it's faster if we multiply the numerator of the complex fraction by 5 times the quantity t plus 2 and multiply the denominator by the same product of 5 and t plus 2. Let's go ahead and do this. 1 over t plus 2 times 5 times t plus 2 is just 5. And then we have minus 1/5 times 5 times t plus 2 is t plus 2. In the denominator we have 5 times t minus 3 times t plus 2. Simplifying in the numerator here, we know that 5 minus the quantity t plus 2 is going to give us negative t plus 3. If we factor out the negative 1, we are going to have negative 1 times the quantity t minus 3, just like we had above. So we would have negative 1 times the quantity t minus 3 In the denominator, we still have 5 times the quantity t minus 3 times the quantity t plus 2. And just as above, t minus 3 divided by itself simplifies to 1, leaving us with the same result of negative 1 over the product of 5 and t plus 2. And again, the simplified function is continuous around t equals 3, and therefore we can perform direct substitution to find the limit. We have negative 1 over the product of 5, and if t is 3, we have 3 plus 2 or 5, which gives us negative 1/25 as the limit. Let's see if we can verify this using a table of values as well as a graph. Since we have the limit as t approaches 3, we have to approach the same function value as we approach t equals 3 from the left and the right. So approaching 3 from the left are values less than 3. We can see the function values are approaching negative 0.04, which is negative 1/25. And if we approach 3 from values greater than 3, as we see here, we are approaching the same function value of negative 0.04 or negative 1/25. We're looking at the graph. If we draw a vertical line at t equals 3, it's going to be hard to tell. But as we approach 3 from the left and from the right, we are approaching a value that's just less than 0. We are approaching the function value of negative 1/25. I hope you found this helpful.